Hello everyone. My name is Anshu Raj and I am a PhD candidate in School of Aerospace and Mechanical Engineering. I work with Dr. Shuzi Zhou and I'm also a co-treasurer of GSC Graduate Student Leadership Team. And today I'm excited because we continue with our spring seminar series and we have an exciting topic, an exciting presenter for today's webinar. And first, let me introduce the graduate student community, also known as GSC. The semester we talking about artificial intelligence, and this seminar is intended to give us insights. For the GSC leadership team, we have two co-chairs, Rodney Hirsch and Samuel. We have Avinash, Hafiz, and Swapnil for publicity. We have we have Siabas and me as a co-treasurer, and we have Jareen, Roshan, Rachel, Shuramya, Biva, Nurayan for the support team, and our mentor is Dr. Farooq Mistry. So, for our GSC regular meetings, we meet every Wednesday at 6 p.m. We usually meet over Zoom. And if you like to be the part of GSC leadership team, please contact Rodney and Samuel. Their email address is given here. And the time is set according to the availability of all the team members. We are available on Engage. If you want to be the member of GSC leadership team, please scan this QR code. And if you click the join button, you can be the member of GSC leadership team. We are also available on LinkedIn. Here you can see the QR code of our LinkedIn page where you can join over our LinkedIn where we post our webinars and so that you can stay informed regarding all the activities offered from GSC leadership team. We also have Instagram and Facebook. You can also follow us here for regular updates about our webinars and the speakers. We have a YouTube channel, and in that YouTube channel we upload all our presentations. So in case if you have missed any presentation, please go to this YouTube channel and search that presentation and also watch for any past presentations. Uh, we This is our office space, Dave and Susan Bird team room. For GSC members, we have different amenities for use: couches, whiteboards, coffee pot, microwave. If you want to have access to this room, please email any of us from GSC leadership team, and we can provide you the access for this room. So another reminder, please make sure that you sign the attendance sheet that we are going to post here in the chat. We keep track of people who is attending the seminar, and this attendance sheet help us to secure funding for next academic year. So for this semester, we are focusing on AI and how AI is exploring the research frontiers with generative AI, how people can work with generative AI to create intellectual, economic, and social values and connect their domains, how uh, its issues and methods and application has been helping people to collaborate across research, industry, and community, how generative AI initiates that link academic inquiry, economic innovations, and social benefits in ethical and equitable way. So if you know someone who is working on AI, please nominate their name to us so that we can contact them for the webinar series. So before we dive into today's topic, just let me give you some announcement about the next webinars. So for the 11th of March, we have Vishnu Kardiala, who is a PhD candidate in School of Computer Science at University of Oklahoma, and he will be talking about latent belief-driven multi-agent coordination. For 2nd of April, Suramya Sarkar will be talking on smart contextual control over Sage archetypes. She is also a PhD student in the School of Industrial and System Engineering. For the 8th of April, Parinaz Dastur, she will be talking about how ML framework for lung cancer screening is done. Without any further delay, it is a pleasure to introduce the distinguished speaker, Dr. Rustom Kanga, CEO of iOmniscient Corporation, an AI company operating across 70 countries. He will be talking about ethics of AI. Dr. Kanga is positioned to discuss this topic as he has been involved in this technology for a long time, having implemented his first commercial system back in 1978. Uh, he is a graduate in chemical engineering from IIT Bombay. He has a master's in management from London School of Economics, a PhD in finance from University of London, and an executive MBA from iOmniscient. He owns over 70 international patents, an organization from Chicago Transit to China Fast Train, 65 airports, and 75 smart cities, including Singapore, Dubai, and several in the US, take advantage of iOmniscient unique AI technology. So today he will address what is AI and how AI can be impacted in the environment, different privacy of the citizens, and understanding the facts, how it is impacting the economy and also the employment. He will also discuss how AI can be used for the good of humanity, and also will provide practical live examples using videos for this. So please join me in welcoming Dr. Rustom Kanga.
So, hello to everyone, and I'm honored to be surrounded by so many eminent experts in AI. So, I'm not going to try and teach you about AI. I'll focus on my opinion on the ethics of artificial intelligence. So, let me start off by telling you a little about what we do so that you understand the context of what I'm going to talk about. Humans use their eyes, their ears, their nose to understand their environment. And that's what we do. We do video, sound, and smell analytics, multisensory AI. We are a 25-year-old company, so we've been doing AI long before it became fashionable. And our systems are implemented in about 70 countries around the world. So organizations like Disney World use us to find lost children. There are organizations like electricity utilities, the police, hospitals, universities, secret service organizations, about 65 airports, 75 smart cities uh, use us. So I don't know why it's moving so fast, but let me continue. So what is AI? AI is about replicating human intelligence. It's about emulating human intelligence. So, what is intelligence? You know, when we think of intelligence, we think of people like Leonardo da Vinci, Stephen Hawking, Shakuntala Devi, and so on. But in fact, intelligence exists in all sorts of creatures. You've probably seen animal intelligence, little cockatoos learning that they can collect food from garbage bins and they learn how to open them. You've probably all heard about Coco, the very intelligent gorilla who was brought up as as a baby gorilla. She was brought up by two psychiatrists, just like a human baby. They talked to her, they read us bedtime stories and so on. And over a lifetime, I think she died recently at the age of 45 or so. And over her lifetime, she began to develop many human, so a lot of human understanding. She had a vocabulary of about equivalent to a young child of about 3 years old. But she couldn't speak. She used sign language, just like deaf and dumb people might. And when they measure her IQ, the way humans measure IQ, she had an IQ of about 80, which is probably higher than a lot of humans that we know. So, what is human intelligence? Because that's what we're trying to emulate. Humans have think in very, very complex ways. As you know, we have sensory perception. We can see, hear, smell, and so on. We have deductive reasoning. We have memory. We have experience. We do creative thinking. We have language. We have feelings. We have conscience. We have all those things. Machines don't have all that. Machines think primarily in terms of memory and experience. There's a little bit of language, a little bit of deductive reasoning, maybe some sensory perception, but it's fairly limited. So AI, when it first started, focused on what we call expert systems. You know, you take a memory dump of how an expert would think. You'd understand his logic, you'd understand his reasoning, and emulate that. Then over time, people developed what we call supervised learning, right? And that moved into things like heuristic algorithms, right? Where you taught the system some basic rules, and the system would be able to understand those and follow those. And the pros of that type of capability is that it's very fast to implement and easy to modify because if you don't like the rule, you can change it. It is fairly computing light. No GPUs were required. The cons, of course, was that it required humans to set the rules. And then you moved into things like deep learning, which exercises the memory function of the brain. So if you want to detect a dog, what you do is you'd get 100,000 images of dogs and you'd label them. You say, this is a dog, that's a dog, that's a dog, that's a dog, and so on. And then you train your system. And next time a dog comes along, you know it's a dog. And the pros of that is that it's easy to do, requires little human intelligence to implement that. The cons, of course, is that it's a very labor intensive process for labeling the systems and images and so on. It requires huge, never ending data because if a new type of dog comes along and you haven't trained the system on that, it won't recognize it. It requires massive computing power because you have very, very large data sets that you have to train the system on. And to a large extent, it's a black box to humans. So it's impossible to provide human input afterwards. You don't know exactly how the AI system is thinking. So you cannot always rely on the results because you don't know if the system is truly giving you the right answers. And then finally, we get into generative AI, which is essentially a very advanced form of deep learning using very large data sets to generate responses based on known human knowledge. And I say known human knowledge because generative AI is based on existing knowledge, right? If you feed it every painting that was ever created up to, say, the 20th century and said, create a painting for me, it would not be able to create a Picasso type painting just because Picasso's paintings have not been part of its training set. So it is good at interpolation, but not necessarily, it's not good at extrapolation. So now let's think of a new problem. A customer came to us and said, how do you detect suicides? We want to detect suicides in the Hong Kong prisons. The point is, how do you get 100,000 people to commit suicide so that you can train your system? The data set does not exist, and it's impossible to create. And that happens in real life. There are many real life situations where there is no data set. So, eh, how do you train your system? So, for that, we've developed a new type of AI called intuitive AI that attempts to use many of the other types of ways in which humans think beyond uh, the deep learning and traditional forms of AI. And with this, we can cope with many real life complexities. We require training, very little training. We can operate with 5 or 10 points in our data sets. We have a quick training engine to train it because we have so few data sets. There's no GPU needed. And you can have very, very fast deployment in hours, days, not months or years. Let me give you a story. Uh, Hong Kong Airport wanted to make sure that their garbage rooms were clean. Now, they have 180 such garbage rooms under the airport. Why so many garbage rooms? Well, I discovered that all airports have hundreds of garbage rooms. Why? Because every plane that lands every 10 minutes is dumping half a ton of garbage, right? And it has to go somewhere. So they said, we want to keep these rooms clean. And they brought in 8 AI companies to do a proof of concept. We were not one of them, but they said to them, you have 4 weeks, train your system and show us what you can do. So after 4 weeks, there was no result. So they said, okay, you can have 8 weeks, then 12 weeks. Still, there was no result. Then they found us and they said, show us what you can do. And we sent in an engineer on a Tuesday night. And on the Thursday morning, we had a fully running system. And that's because we could train the system on very, very few data sets. So that is what AI is. It's been evolving over the years, and the question now is for any new technology, you have to worry about the ethics of using that technology. Is AI good or evil? Uh, that's true for any technology. You can use a knife. A knife is a technology evolved by humans. No other animal has it. So it can be used to cut a birthday cake. It can be used to kill someone. Similarly, with nuclear technology, it can be used to cure cancer, to treat cancer. It can be used to make a bomb. So all technologies have this issue. Uh, and even the definition of what is good or evil, what is good? The guy on the left is a good shot. Uh, Person on the right is a good person. So we've used good in different ways, right? So what in fact is good? So even humans struggle with the ambiguity of words, with ethical questions, and issues of what is right, what is wrong. So let's think in terms of several areas where AI can impact humanity. We worry about sustainability, privacy. How accurate are the systems? Can we rely on them? Do they impact our economics? Do they impact employment and things like that? So let's talk about sustainability. Um, uh, you know that LLMs require a large amount of electricity to train. That's why people are building these huge data centers. Google estimated that for them, a typical LLM requires the same amount of electricity as it would take to power a TV set for 182 years. That's many, many lifetimes. If you were just watching it day and night for 182 years, that's the amount of electricity it would take to train one LLM for Google. That's an enormous amount of electricity. Now, Sam Altman has said that it also takes a lot of energy to train a human. So it's not bad to expend energy to train an AI system. However, is it equivalent? So should we not train humans to be better humans, right? Is it exactly the same as trying to train a computer? So now, looking at uh, what we do with intuitive AI, one of our challenges was that we wanted to produce systems that were ethical. So with AI, because we require very little training, we can reduce the number of GPUs. In fact, we don't use any GPUs at all. And by not using GPUs, we reduce the carbon footprint of a system that we implement by about 16 times. This definitely helps to make the system sustainable. And that's very interesting. That's a picture of my business partner, Ivy, along with Lip Bhutan, who's the Intel CEO, the new CEO of Intel. And he met us within the first 2 months of taking office. Why would he meet a little company like ours? And that's because we do AI using intuitive AI, which is great for Intel, and they love us. Uh, and Year ago, they made us their alliance partner of the year, and so on. Of course, at the same time, NVIDIA hates us because we don't use GPUs, but then that's life. So let's talk about privacy. Uh, People are always concerned about face recognition systems. They're worried about Big Brother watching you. Well, that is true. But of course, when you have CCTV systems everywhere in railway stations and shopping malls and so on, they're watching you anyway. And anyone can see what's on the CCTV system. So all the CCTV systems are not privacy protected. So why are we worried just about face recognition systems? Um, well, face recognition systems, in fact, provide a level of intelligence that goes beyond what just dumb CCTV systems provide. So, in our own system, we've developed a specially patented privacy protection capability where you can redact all the faces. So, as you can see, nobody's face is visible. But then, if nobody's face is visible, is the system useful for security personnel, for instance? So let's say there's a murder in the shopping mall. What do you do about it? Well, we've encrypted the redaction so it can't be removed, but we provide a key to authorize people. So if there's a murder in the shopping mall, then an authorized person can come in and reverse the redaction. And that makes it fully GDPR compliant. What is GDPR? GDPR is the European legislation on privacy, which is perhaps the strictest privacy protection legislation anywhere in the world. Let's consider another aspect of AI. AI systems suffer from what they call hallucinations, which is essentially accuracy problems, right? Uh, are these systems accurate? And how do we know they are accurate? Because they're usually black boxes. We don't know what's happening inside the black box. And so you put garbage in, you could get garbage out. You have the issue of chatbots being hacked. And what happens when an AI cannot make a correct determination, right? You ask it a question and it doesn't have the data to make the right determination because it hasn't been trained on that aspect of the question. What does it do? It guesses. And that can be quite a serious problem because you don't know whether it's guessing or whether it's giving you a correct answer. And this is particularly a problem in our field, uh, which includes things like face recognition. So let me show you what I mean by face recognition. You've probably seen it in airports where people say, stand straight, take off your specs, don't smile, and they recognize you. We do face recognition in a slightly different way. We can do it like that in a crowd at a long distance at 20 or 30 meters, which is for the Americans about 60 feet. Uh, with 100 people coming at you, we'd recognize them. This is on a low resolution camera without a GPU. So, in a situation like this, what do we do about the privacy of all those other people? Well, we can redact all those other faces, and only the person of interest would then be recognized. But even so, these systems can make a mistake because let's say it is 99% accurate. That's great for the 99 people out of 100 that it recognizes, but it means you're getting one person wrong. And an innocent person may be caught for doing something. So, what we normally highly recommend is that we combine human and artificial intelligence. So, for police organizations, for instance, we recommend that they don't use the AI system on its own. So, in face recognition, an AI system is good at taking a million faces and figuring out who the 10 most likely matches are to a particular person. But a human is not able to process a million faces. But if you give it 5 faces or 10 faces and say which one of them is Johnny, a human is quite able to say, oh, that particular guy is Johnny. So a human is able to take a small amount of data and very accurately uh, match a face, which is unlike what a system can do. A system is good at processing a million faces, but it's not accurate at that very granular level. So by combining the two, you can in fact get a very accurate result. So that's what we normally recommend, that you always have a human input into some of these systems uh, where the accuracy is of utmost intelligence. And therefore, recently you heard there was a controversy about the US Defense Secretary wanting a company called Anthropic to deploy unmanned weapons, right? In my view, it would be very dangerous to force Anthropic or any company to try and deploy unmanned weapons because an AI system, even if it has a small amount of inaccuracy in it, right, that can be extremely dangerous. It's really important to inject that little bit of human intelligence that can complement what AI systems can do. Okay, so how does AI impact the economy? Right? The real question is how much does it cost? Is it worth doing? Because if you have all these big data centers that you require and GPUs and all that, you know, it's a very expensive way to develop intelligence. So how much does it cost? Well, for our own system, I don't know how much other systems cost. That's really dependent on those companies. For our own system, we position our systems as costing a cup of coffee per day per camera. So if you can afford your cup of coffee, you can afford our system. And how do we do that? We've designed the system by design. We've designed it to reduce the storage requirements by about 90%. We reduce the network requirements by about 90%. We don't use any GPUs. We require less manpower to run the system and so on. So in terms of the cameras that we use, we can use very low resolution cameras. That face recognition video I showed you ran on a 2 megapixel camera. Your phone probably has 10 megapixels on it, right? So, for instance, how many cameras do you require to protect an airport? Traditionally, it used to take about 3,000 cameras, and people put in more and more high resolution cameras. Uh, because we use very low resolution images and videos for processing, in a recent project, we were able to reduce the number of cameras you required to only 650. So overall, our focus is on making these systems much more economical than they have been in the past. Let me show you how we compress the video, right? Because I said we talk about storage, we reduce the storage by 90%. How do we do it? Let me show you a little video to show you how that happens. Now over here, there's a car park. You'll see that man. He's wandering around. So if he does something suspicious, we'll want to catch him. Look at the car, the white car. It's parked illegally. If so we want to catch him. He's not in the proper spots. So let's see what happens to that first guy. He's checking out cars. The system will detect that. It'll zoom in on him. He'll say, "Who's this?" When he turns around, we'll see his face. We can do face recognition on him. It sees the car. We'll recognize the number, read it. So what were we doing over here? We were taking a very high resolution video, probably 5 megapixels. We were reducing that video to zero point 0.1 of a megapixel because that's what all you require to recognize behavior. And when you see a behavior you don't like that man loitering or this car parked illegally, you can zoom in on it and pull out that information at high resolution. So you can pull out the face at high resolution, the number plate at high resolution. So essentially, we were uh, pulling out the important things at high resolution and keeping the rest of the image at low resolution. And doing it that way, we can save about 90% on the size of the video. Uh, and that reduces the amount of storage you need. That reduces the network bandwidth you need to transmit that video. What is the value of this, the financial value? So we did a recent project with the Bahrain prisons. We did 2 prisons over there called Jao and Hid. And they said, "We love your technology. It's fantastic, but we have no money." That's always a problem with customers. They say they have no money. We said, "You're going to spend $2 million on this project. So you obviously have a little money for us." And they said, "No, it's all allocated out. We have to buy computers and cameras and networking and this and that. And your software is an extra $600,000 on top of what we are going to spend. And we don't have that extra money." We finally convinced them to implement the whole system. And they saved $800,000 just on the storage. So the whole project came in at 1.8 million instead of 2 million. So the value proposition we give to people is exactly that. A system can cost less than a simple recording system. And the smarter you make your system, the less expensive it gets, because the system, as it becomes more intelligent, we've designed it to use less infrastructure rather than more. And the big issue, of course, is it going to affect employment? And the answer is, of course, it will. Vinod Khosla, the entrepreneur, said college degrees are dead. There may be no jobs for professors in the future. Why? Because you'll have AI systems which will educate our students. Now, that's an interesting concept. But when you think of motor cars, at the start of the 19th century, a very lucrative job would have been that of saddle makers. At every corner of every street, you'd get a saddle maker's shop, and you had thousands and thousands of saddle makers around the advanced countries. Today, you don't have any saddle makers because the motor cars came along and destroyed those jobs. It's very difficult to find a good saddle maker now. So does that mean the motor car killed all those jobs? Of course it did. But it created many new jobs in the design of motor cars, in the manufacturing of motor cars, and in the driving of motor cars. Today you have bus conductors and you have bus drivers and truck drivers and chauffeurs and so on. And of course you can move much faster because of the motor car. So is it a real problem if a new technology kills old jobs? Of course, it seriously impacts the individuals who are involved in the old jobs. but I think that's up to society to retrain those individuals and so on. So if we have all these issues, which we try to mitigate, as I said, in industry, but we do have all those issues. So is there a value in AI? What is a positive value? Because if there's no positive value, why would we implement these technologies? So let me give you an example of positive value. You know what happened at the Louvre. Some thieves broke in, they stole some jewels and so on. It took them 5 days or so to catch the first few suspects. But of course, jewels seem to have gone forever. So the question is, could it have been different? They had all these advanced technologies in the Louvre. Why could they not catch those guys faster? And the reason, of course, is that they had all the cameras there, but they did not have the intelligence in their systems. So people put in these, thousands of cameras, and they have these large video walls and control rooms, and they expect this poor man sitting over there to actually see something. And studies have shown that if you're watching just two monitors, after 10 minutes, you miss half the action. After 20 minutes, you see nothing. So there's no point in having these sort of advanced systems or these video walls and so on. But if you don't have video walls, then how is anyone going to monitor all these cameras? How are you going to see what happens? So let me tell you a different story. In Singapore, they had a riot in a place called Little India. A bus ran over a laborer, it killed him, his friends got upset. It became a riot. So see the timing, 9:21 the accident happens. 9:25, 2 minutes, the police are there. 8 minutes, the ambulance has arrived, then the fire brigade. In 1 hour, they've all gone home. Next day, 24 people are charged. How can Singapore react in 2 minutes? And in France, it takes them 5 days to do something. Well, in Singapore, we implemented our autonomous response system. Note that this was in 2013 that we did that the riot happened. So before that, we implemented a capability which today is known as agentic AI, which is where the system understood what was happening. The cameras themselves automatically found the nearest police car. It found the nearest ambulance because the car was on fire. It found the nearest fire brigade automatically and told them where to go and what to do. I'll show you a little video that explains how this technology works in detail.
iOmniscient's speciality is the ability to provide multiple video analytics in very complex scenes. As you can see, a person has dropped a bag. He has abandoned it and he is walking away. The bag is being obscured by people walking in front of it and it is hardly visible. The system has found the bag. This is our speciality. We can cope with situations where the object is significantly obscured. We now do the jump to event, which takes you back to the moment that the bag was first brought into the scene. It doesn't matter how long back that was. The system can see who left the bag, it can pull out his face and enroll him in the watch list. This face can then be transmitted to all the other cameras within the network. At this stage, we don't know who that person was, but we do have an image of him, and we can search for him across the various cameras in the network. Now, in this view, we have seen the person again, and we can pull out whatever additional information we have about the person. The next step is to track him. We can track him on different cameras where we have seen him, and we know that he is finally now at that last camera shown in red. From that point, we can find the nearest policeman, and the system sends the information to him on his smartphone. He will ask who this person is, and we can send him as much information as we have on him. He will ask what he has done, and we can send him the jump to event video. The entire process is patented. The ability to find a bag in a crowded scene, even where the bag is obscured, the ability to do the jump to event, and to see who left the bag there. The ability to do face recognition in a crowded scene in a totally uncontrolled environment. The ability to find the nearest policeman, and in fact this entire process of automated response is patented by iOmniscient.
Now the value in Singapore was it used to take them 45 minutes to respond to a street incident. They were able to reduce that to under 5 minutes. And of course, that reduces congestion on the streets if the police can arrive faster. And if it helps the individual, if you're the person with your leg under the truck, then it certainly helps if the ambulance can get there 20 minutes earlier. So, what did you see in that video? You notice that all the sensors are operating like one giant brain. It's not, can you do face recognition on camera 10? It's all of the sensors are working together. So camera 10 might say, somebody's left a bag here. Camera 200 will say, yeah, the guy who left the bag there, now he's in front of me. So from here, I need to find the nearest policeman, right? So this sort of system, by the way, as you saw, was already operational back in 2013 when we did the Singapore Smart City. So that was just an example. Now, that sort of system relies on a whole bunch of underlying technologies, for instance, behavior analysis in a crowd, all types of behavior, theft detection, slips and falls, fighting, graffiti detection, and so on. So you have all these video-based analytics capabilities. I mentioned we do video and sound and smell. So we also do sound. We do 100 different sounds. We can detect gunshots, children crying, people shouting, glass breaking, and so on. And sounds can be useful in many human enterprises. For instance, in manufacturing, you might have a conveyor belt that's processing a product, and we would be listening to the sound of the conveyor belt. And if the sound pattern changes, we know there's something wrong with the conveyor belt. You can stop it, you can fix it before it breaks down. It helps with predictive maintenance. And then we also do smell. Now, how do you do smell? For video, you have cameras. For sound, you have microphones. For smell, what you require is an electronic nose, an e-nose. It actually doesn't look like that. It looks like this. So as the air goes through it, it'll tell you what's in the air. Why do you need that? Because you do get chemical sensors for chemicals. So, for instance, police use it for testing the breath of alcoholics or people who've been drink driving. But there you're looking at one single molecule, alcohol. But in most industrial smells, they are much more complex. Like a cup of coffee has 400 different molecules in it. So to know that it's coffee and not tea, then you need our enos. What is it used for? In a host of different environments. For instance, for cleaning toilets in airports. They might clean it every 4 hours, but it might start smelling after 20 minutes. So the toilet itself will say, I'm toilet 6, come back and clean me. We use it in food production, in dairy farms, dairy production, for instance. They bring in milk from all the farms. By the time it comes to the factory, it might have gone off. So it'll smell the milk and say this is good milk, it's bad milk before they start processing. It's used in hospitals. A patient might be incontinent, the room will start smelling. The message will go to the nearest nurse saying, go and help the guy in room 26. The room is smelling, things like that. And we've developed another capability called Dr. Nose, where we can smell the exhaled breath of an individual, and it can be used for the diagnosis of early stage cancers like lung cancer, breast cancer, a whole bunch of different cancers. The clinical trials we've done have demonstrated that the system has a higher accuracy than the traditional methods we use, like MRIs. Accuracy can be 77%. Mammograms are up to 85%. This system gives you an accuracy of up to 95.2%. So it's more accurate than the traditional methods. It's less expensive, less intrusive. That's the value of AI. Take another example, escalators. We worked with one of the railways in Asia, and they had 5,000 escalators, and at any time, 10% of them broke down. Why? Because, well, first of all, nobody even realized that this was a problem because the IT department doesn't worry about this. This is a maintenance problem. The engineers worry about it. But they were spending an enormous amount of money on the maintenance. So they came to us and said, what can we do about it? We looked at it. We found that the problem was that little nuts and bolts and coins and so on would fall on the escalator. And you can see it over there. You can brush it off and stop the escalator and avoid it from getting uh, damaged. The focus, as I said, was not for the IT department, but the return on investment was enormous. The payback period was 8 weeks. So when they implemented it, they saved millions of dollars. So that again is the value of AI. In hospitals, one of the key problems is that people fall down and they fall down in the bathroom. And so, how do you detect that? Because otherwise, an old person might have fallen down and you might not see him for 5 hours. So, we've developed a system that is totally privacy protected for hospitals. So, for example, uh, all you can see is the outline of the person, right? And if he falls down, the system will recognize it. You can will raise an alarm and let the nurse know. But it's totally privacy protected, as you can see. You don't see anything other than the outline. Let me give you a final use case that is extremely interesting. What happens when you lose children?
Children can often get lost or go missing in crowded places. Every year, thousands of children are lost, sometimes by accident and occasionally through a malicious act. You can help minimize such incidences in your facility. iOmniscient's highly accurate systems are designed to cope with the crowds and help reduce incidents of missing or lost children. The following scenario shows you how the technology can assist you in resolving and addressing missing children in real time. A worried parent is reporting their missing child in a shopping mall. The retail assistant calls in the nearest security guard to help address the situation. The guard uses their smartphone loaded with IQ Mobile to take a picture of the parent or guardian and enroll their face in the face recognition system. The guard can then search for the parent and find when they first came in the shopping mall with the child. Having extracted this footage, the guard can see the parent walking in with their child, and based on that, the child's face can be enrolled in the system. Now the guard can search for the missing child across all the CCTV cameras in the network. It will track the movement of the child in real time and tell you where they have been and where they are right now. iOmniscient's highly automated response system, ASAP, then locates the guard who is nearest to the missing child automatically, based on the GPS in their smartphone. It will send this guard the information on the child with a picture and tell them to make contact with the lost child. In no time at all, the parent is reunited with their child. This can be done within a matter of minutes and can prevent a lot of trauma for both the child and for the parent.
So, you saw there are many, many positive things that you can do with AI. And our focus is on doing the positive things. There are also limitations on AI, and we have to recognize those. Can AI be truly creative? Can AI develop feelings and a conscience like humans? You never know what systems will be able to do, 10 years, 50 years from now. Because certainly 25 years ago, when we started a company, we could not imagine the things that we are doing today. But in my own view, I think there will be many of these areas like creativity, conscience, and things like that, that will always be the domain of humans. And that is the reason why I think we have to always think of humans being part of this intelligence ecosystem. And the question we have to ask ourselves all the time in industry is, can we use this technology for good? Because ultimately, any technology, as we said, can be used for good or for evil. We certainly try and position ourselves as the ethical AI company, and I think you could see in the types of things we do and the way we think that that is a core uh, aspect of what we do. So thank you very much for your time. I'm open to taking any questions.
Thank you so much for your excellent talk. We are running out of time, so please unmute yourself if you have any questions. We can take a couple of questions, or you can also write down in the chat and I can read it for you.
I have a few questions. First of all, thank you so much for your presentation, Dr. Ganga. So, my first question is if you can mention, like, very shortly, what is the mathematics behind the method you are using? Is it like a logic function, like probabilistic method, something like that?
Uh, Actually, there's no one single algorithm for
Mm-hmm.
this, right? As I said, humans think in many, many complex ways. We use deductive reasoning, we use our memory, we use our experience, do creative thinking, and so on. So, in fact, in certainly in the concept of intuitive AI, it adaptively includes many of these different aspects as required in the thinking, right? So it's not using a single method
Mm-hmm.
for doing the calculation.
Right.
Okay.
Thank you. And my next question is, as you are mentioning some analytics like smell analytics, sound analytics, videos. So I was interested if those are necessary to implement those the method you mentioned. Uh, I am asking because I am working with fuel cells and in my research, so generally I have to work with a complex physical system. So
Mhm.
I was curious that if I use like a small data set, so will it be physically accurate when it encounters a scenario outside its very small training data set?
Um, well, it depends on the algorithms you've used, but certainly we found that, say, for the face recognition system we have, we use a data set of about 50 faces to set up the
Mhm.
system. Other people use like almost a billion faces, right? And our system is as accurate using intuitive AI with that very small data set as others do with their traditional machine learning, deep learning. So it can be made very accurate. It depends on how, on the algorithms you use, right?
Mhm.
It's really as I said, humans actually operate with very small data sets. We, as humans, we can't process huge amounts of data, right?
Mhm. Right.
So we really have to emulate how humans think
Mhm.
to achieve the result with a relatively small data set.
Right. Thank you.
Anyone else?
So it seems that you have tried everything you can to reduce the amount of hallucinations that you see, but still it's not maybe 100,000% accurate, whatever it is. How can I train or help humans understand when there is a hallucination?
Well, it's very difficult, especially with if you're using a deep learning system, to know uh, whether there is a hallucination because the system doesn't tell you, and people have this tendency to believe that, oh, the AI told me, so it must be
Mhm.
true. So I think we just have to be sensitive to the fact that AI systems are never 100% accurate,
Mhm.
right? We just have to be skeptical. We have to always exercise our disbelief and our doubt and say, are we really sure? But
It's
I'm not sure there's a way to actually know if somebody's lying. It's like that.
it's particularly difficult when you're trying to teach students. I mean, if you've got somebody that's had 20 years of experience in the field, they probably can say, oh, well, this doesn't quite seem right. But
That's
if a
right.
student comes along and says, okay, the AI told me, then what?
Yes, you're absolutely right. And of course, in real life, you face the same problem. Humans face the problem, and with politicians saying this is reality, and
Mm,
some people believe it, but many others know that it's not.
mm,
Right.
that's true.
Yeah, I
I
had a
have
similar
one
question. Oh,
question,
sorry. Go ahead.
if possible. Go
Yeah.
ahead, please. Great presentation. Thank you for presenting. I couldn't introduce myself because I joined lately. So my name is Pejman Kazimkar. I'm associate professor in the School of Aerospace and Mechanical Engineering. So I
Right.
have one question, especially, and this is not related to the material. It was kind of very helpful. I wanted to ask about, like, you put patented in many cases, and I
Yes.
want to get better idea about, like, for especially like considering AI work and kind of integrating some of this technology, how you can secure your patent, especially we have some ideas that we can do certain stuff, but now with AI and everything you see around, sometimes securing these patents would be a little difficult because you don't know how people they use it. Can you give me some recommendation of how you can secure that? What would be your approaches?
Yes. Well, uh, as you would know, in a patent, you've got to disclose everything that you've all the knowledge, right? So that it can be
Yes.
replicated. That's the whole idea of a patent. Uh, and if you do that, then anyone can copy the patent. And of course, patents, even when we say it's internationally patented, it's only patented in certain countries because you have to patent it country by country by country.
Yes.
And you'll always find someone in some country somewhere where it's not patented, copying it and stealing it and so on. So what we do is we patent the core technology and then we surround it with trade secrets so that even if you copy the patent, you you can't actually make it work
Okay, I
because there
see.
is stuff around because you don't have the trade secrets, the knowledge around it that is required to make it work. Right. So
Okay.
that's how we secure the patent. So when we say there's 70 international patents, there's also a very large volume of stuff that is not patented that surrounds it.
Okay. Okay. Makes sense. Thank you so much.
We see that in nuclear power all the time, right? You can patent a certain type of design, but if you don't know how to refine uranium to the correct load or percentage, then you can't make it work. I'd like to tie into
You're
a
right.
little bit to
Yeah.
what Dr. Allen was talking about. The difference between, I write policy for Marine Corps headquarters. I use AI all the time in that capacity. I know that when I put my name on that policy and I send it to my government reviewer, right, that's my name on it. And I need to own 100% of what's in that paper. What we've, this is somewhat subjective, right? What I'm about to say, but what I've seen, especially with the kind of like no AI in education policies, right? What ends up happening is it gets used anyway. Then when they get a C, they say, well, that's because OpenAI needs to get a better model, and they don't own the fact that, hey, if you choose to use AI, right, technically that's against the rules. But my point is, the society is saying that that's fine, but you need to own what you turned in, right? And we're missing that opportunity. And in your work, you talked about how you use your technology to go from a wall of 99 cameras that one person can't possibly actually look at, right, to help your AI. But then when someone says, yes, that's a threat, I'm sending it up, how do we make sure that those people are owning that and not saying, kind of like what you did? I remember you did say a couple of times in the presentation, oh, well, AI told me that that's so. Or
Yeah. Yes. I mean, your observation is absolutely correct. I think the challenge with AI is that humans have tended to accept AI as an alternative to doing their own thinking. And they, as you say, they need to own it. You can use AI as a tool, but in the end, you've got to own the final decision as a human.
yeah, it's a tool, right? And when we use the wrong hammer, and as a mechanic, and we break the customer's strut, we don't say, oh well, they should have given me a better hammer. I mean, I just have never heard such a thing. It doesn't happen. The mechanic by default owns it. But how do we keep AI? I mean, it seems like it's a natural tendency for people to just kind of move the responsibility over. Is it because it's become anthropomorphic, or is it something else? Over.
Well, I mean, what you've said is absolutely correct. I think it is because people think that it thinks like a human, and you tend to believe it, right? But I think that's why I'm talking about the ethics of AI, because I think it is so important not to just accept AI as a given. We've got to understand its limitations. We've got to know what it can do, and it can be of great help to humanity, but we also have to know what it cannot do, and we have to accept it and work within those limitations. And there's a high risk that with people who have a lower IQ than that Coco the gorilla, there's a high risk that humanity could lose control of itself because it accepts that AI is actually more intelligent than itself.
Yeah, I'll close with saying that my recommendation is that we develop, especially in learning communities like university, we develop places where AI is explicitly permitted, but we have a way to ensure that everyone knows that they are the ones who are going to be held responsible, and it gives them practice with using this tool, right, as a tool, knowing that it's their name on the line. Over.
That makes good sense. Thank you.
Maybe Dr. Prakash, if you have any questions or any suggestions.
Yeah, thank you very much. It was very nice to see you. We have also developed some of the technologies in the area of reduced computation for image processing. So I would like to get in touch with you later at some point. Maybe you will be interested in some of our patents if you are into the business of acquiring patents, but we can discuss that offline. Other than that, I think just to comment on the question about how to patent this type of stuff. So there's a tricky situation that a business method generally is not patentable in most of the world, but United States is the most favorable. And this patent, one particular patent which I have shared in the chat box, that gives a sample of how to basically patent by showing it as some physical equipment should be attached to the method. So it's possible to patent, but more favorable it is in US, but other countries, many countries don't allow business method patents. So that was just a comment which I wanted to share with the others. But thank you for sharing this great presentation. It's very interesting. Thank you.
Thank you.
Dr. Kanga, thank you so much for your presentations. Very interesting. Do you see a translation? I know that videos are very different from medical and dental images, but medical and dental images are stacks, 3D stacks of 2D images. Do you see a translation of this technology for that purpose? And then touching upon the ethics of it, do you foresee human subjects protections being an issue for this technology?
Yes, it is absolutely applicable because video, after all, is just a sequence of images, right? It's exactly what you're talking about. So when we say we do video to find lost children, it's the same as looking at an MRI system, for instance, right? What are the ethics of doing that? I think, again, it's important to understand the limitations of the technology. That's it. So the technology can give you very good information, but you've got to understand its limitations. For instance, with our diagnostic tool, the medical device for using exhale breath, right? It is only 95.6% accurate. So is it useful? What people have asked me, what if it's wrong? And you diagnose me with having lung cancer and you're wrong. I'll sue you. I said, yes, but if you use an MRI and that's only 90% accurate, are you going to sue the guy who gave you the MRI? It's you've got to understand that it's a tool. It'll give you perhaps better information than you've had in the past, but it's still not 100% accurate. You've got to add your own experience, your intelligence, and so on to interpret that information.
Yeah, I particularly find it very interesting because, we have to use a large training data set in order to really get a high level of accuracy, if you will, of detection in at least the dental imaging AI. So being able to use a much smaller data set and yet get very comparable accuracy rates would be amazing, I think. So you've kind of got my mind reeling in this way. So.
Yes, we've never done work in that dental space, but maybe we should get in touch and see if there are things where we could help you.
Would love to. Thank you. And thank you for your presentation.
Thanks, Sharu.
Farzan, do you have any questions or any comments?
I don't have any questions, but I found the presentation very interesting and I have a lot about to think about now. Thank you.
Bucci is in the United Kingdom. Bucci, you may like to unmute yourself and join the conversation. Okay. So Rustom, closing comments?
Well, I am very honored to have been invited by this very eminent group of AI experts to talk on a subject that many of you probably know much more than I do on it, because I'm actually not a real expert on AI. I just run the AI company. So thank you very much for listening to me, and I hope it was useful.
Thank you. Thank you very much indeed. I greatly appreciate it. I'm going to stop recording, and what we do typically